How's it going, people of the internet? I am Ronnie, and today I will be teaching you how you can take your API, your FastAPI projects, and deploy them to the web realistically. Now, you don't need to buy any VPSs, you don't need to buy any host names or domains. This is a totally free method on how you can get your API to the web delivered to the public for absolutely free. Now, one of the main disadvantages of doing this instead of a VPS, I will be realistic. You will need to have your project running on a computer. You can't deploy it to the web and have it expected to be on there. This is not something like Heroku. You will need to be running this. But if it's a project which you don't want to pay the hardware requirements, equivalency of what you already have to run your application, then this is the method for you, and it's a method for me as well. So let's get started. So we're going to be using FastAPI. Now, FastAPI is a bit different than Flask. It depends on Using-traefik because it's made on top of Starlet, which is, I think, the fastest Python web framework out there. I think I might be wrong on that, but this is a very reasonable framework to use if you want to make APIs and make them fast. So let's go ahead and just create a simple FastAPI project. So import FastAPI from FastAPI, import FastAPI. And when you make an app, you don't need to use the dunder name. And we'll just say app.get, and we'll use index, and no fancy schmancy schemas, just return a JSON. We'll say message hello world. Okay, now in order to run this, we have to use the command line. So before we do that, make sure you have installed FastAPI. So -m pip install FastAPI, and there we go. So you can see it's using Starlet, which is a really fast framework, low-level framework. And let's get this up and running. We're going to use UV-corn from the command line. I'm going to say UV-corn app, and then we're going to use the name of the variable we gave to the FastAPI instance. I'm going to say app, and there we go. We're up and running. So if we were to visit this site, the main one, we'll get the response. Sorry, this is an extension for JSON viewing. It's pretty cool. But basically, you can see the API is working. Now, the issue with this, right, you can't just use your there is a method of getting your app out there, which we can say host equals, and then you can use the 0 method, which allows everyone on your network to be able to view your API. So my local IP, let's go ahead and see IP config. Where is it? So it would be your Ethernet adapter Ethernet or your wireless LAN adapter, and it should be the IPv4 address. Now, this is my local network's IP. If you were to go on your network's router gateway and see where your connection is, that will most likely come up. So let's go ahead and enter that, and bam, it works as well. But you can tell it's not running on HTTPS. Otherwise, it would not say not secure. That's one of the issues. Another issue is if I send this link to someone, they won't be able to see this message right here. Now, if you want functionality like that, there's a few changes we need to make to our project. First of the changes would be making a Docker integration into your application. Now, if you want to get up and running with if you want to Dockerize your Python application, this is an overarching Docker crash course, you could say. In order to Dockerize your project, you need to make a file called Dockerfile. You can see the icon library picked it up. If I was to write something like app, it would work as well, but this would not be a valid naming instance. If you want to differentiate, you could say full stop and then write your specification. But it's most helpful to just keep it simple and write the naming convention Docker file. Now in here, there's a few umbrella commands you could use. I want to use the latest version of Python, so we'll say from, and then we use Python, 3.11, and this is just it's a random repository. Sorry, you need the full stop there. This is a random repository someone's made. It's very easy. It's like pip installing a library that you need for your project. So we'll go ahead and select Bullseye. Just keep it nice and simple. Feel free to just copy and paste this because this is OS related regulations. You're installing some essential libraries for your application to run. Doing this, it would already come with it, but you don't want to have any headaches later on the line because some project is missing. It's very hard to diagnose Docker on an OS level once that's already happened. So now, run commands are very useful because you can have a lot of them, but you shouldn't have a lot of them because every single purple highlight you see, that's a layer in Docker. Now a layer is essentially a command. If a layer fails, you know that it's not going to go downward. So we're starting from the top layer. And if this is corrupt, it's not going to bother working on this because why would it waste resources on a corrupt project? Because all of this ties into one virtual machine. So we're gonna update Python, and then we're gonna update pip. So we're just gonna write pip3. Now this is running Linux. Docker is synonymous with Linux virtual machines because they're very lightweight and they allow for a lot of tinkering and customization. So we're going to be using the pip3 and we're going to say install upgrade pip. Very simple. And then what we need to do now is we need to define our user. So we're going to say user is root just to avoid any permission errors because Linux has a lot of permission errors. We're not really doing anything OS related. We're just running the application. But it's a good thing to define this anyway because it's an insurance policy against some of the things you might run into when doing Python with Docker. Now we're gonna say our work dir, so work directory. Now this is the directory of focus. We only have one directory. We can't just say this is the whole directory because Docker doesn't know that. So we need to say /app because we're doing Linux. Now that's done, we need to do a very important step. We need to make a requirements.txt file because Docker needs to know exactly what files to create, what libraries you need to install for this application to work. Now, if we go back up to over here, is there an easy way to find what version we installed? Okay, we'll just say this. So we'll say FastAPI equals bang. Okay, and now we need to take this file and paste it in here so that we're using contextual directory in terms. So it doesn't have to go back and forth using change directory commands. So everything just gets put into one blob and that blob works. Okay. To do that, we say copy and you can see it says source and then destination. So we're going to say our source is just requirements.txt. We're going to say these two expressions because they're signifying to the root. And then it's already telling us already. So we've defined our work directory and the IntelliSense is telling us this is the work directory. So it makes sense to place it in here. So that's what we're going to do. And then we're going to write requirements.txt. So now that's there. We're going to run pip3 install -r for requirements and then requirements .txt. There we go. I might just make sure that we're using the right version. FastAPI version. So what is the latest version? Okay, we should use the latest version. Don't know why it didn't give us install the latest version, but anyways. Now that's happening. We need to expose the port. So in order for the port to be actually... So virtual machine isn't a small word for Docker. It literally creates a virtual machine for your application to run in a very lightweight form factor, but it is running a full-fledged Linux operating system. So in virtual machines, networking is tied to the internals. It's not external. So in order to solve that issue, we're going to use the expose keyword. And the port that our application was using was 8000. Now, if you want to run your application on a different port, you can simply use the port flag. We could say 5000. It's mainly used for React. I'm not really going to bother with that. We're just going to stick to the basics. So with what we already have, we're going to say expose 8000. When you use expose, it's talking about the ports only, nothing else. You can't use expose for like expose this directory or like expose this environment variable. It's only used for ports only. So now what we're going to do is we're going to copy everything here, because sometimes you could have like a config file, like let's say config.py, because you want every single thing inside of here to be a config. We could say data equals, we could say config equals, and we could have a JSON like saying mode, and we could say production. And this could be imported from deep directories, and we can use these config variables to work with that, but we don't have any of that, so we're just going to leave that alone for now. And it also helps if you have a main file logic to use copy. I do apologize about that, dog. That is obnoxious. So copy app. So that's basically, you know, we don't really need that for now. We're gonna keep it nice and simple because we are using a lot of layers over here. So we could say env listen port equals 8000, because we just want total focus on that port alone. We don't want any other ports running. And furthermore, the last instruction for your Docker file has to be a CMD. Now, what we did to run this application was python-m uvcorn, and we used the name of our directory and then the name of the variable, and it would run the server for us. We've also got a host flag. Very simple, very simple. CMD is the last instruction that's in your layer. You can't have more than one CMDs. That's what run is for. But run is to make sure everything is already configured. You've run your OS operations, and CMD is to run your application. So it runs like subprocess popen. It takes an array of instructions. So first instruction is uvcorn. Okay. Second instruction is app, and then our app variable. We're just following along with the spaces. Every space is a new element inside of the array. And we've also defined our host variable. So we're going to say 0.0.0.0. Bang, bang, bang. Now, we could run this as it is, but it kind of gets a bit difficult when you're using Docker alone. So in order to make things a bit more simplistic, we're going to use something called Docker Compose files. Now this is getting a bit advanced, but it will save you time in the long run. So Docker Compose is basically if you want to make a group service or a network of services. Say if you're running PostgreSQL, if you're running Redis, RabbitMQ, and they're all running on Docker, you don't want them to be separated. You want them to be united so that they talk to each other in a more optimized manner. Now, this is very optional. You don't really need a Docker Compose file, but it's very essential to know Docker Compose on top of Docker. Docker isn't going to get you far enough. So in order to be more, not more complicated, but anyways, let's just go ahead. I don't know what I'm saying. So the way this works is you need to define a version. Very simple. This is a YAML, so we're going to use YAML syntax. We're just going to use version 3. That's very specific. Version 4 hasn't come out yet. I don't even think it will. So when we say networks of our application, what we mean is services. So this services, it basically groups everything as a parent. So everything below this we could use as a separated service, but united through the services thingy. So next up, everything inside of, so the next level below services would be the name of our applications. So we're just gonna call it app. All right, we've called it app, and now in order to build this Docker file, we're gonna need to say build. Okay, that's another level. Now inside of the build instructions, we're gonna say context is dot. So current directory, the Docker file is right there. Okay, we don't use commas. This is like Python indenting logic. And the next instruction is going to be the Docker file instruction. So that would be the name of our Docker file. Now this is where Docker Compose gets very helpful. If I was to write .app, right, and I would try to run it in the command line, I would have to use a /f flag to specify. But with Docker Compose, you simply just write the name of the file itself. So what is the name of our file? It's dockerfile.app. Simples. Now, in our Docker file, we've said expose 8000, and we're going to say that here again. We're going to say expose. I'm going to say our port 80. And then we're also going to define, so this is TCP and then UDP. Bang. And we also need to define our ports. Same thing. 8000 and then 8000 again. Although we could just avoid having to expose the UDP. TCP works anyways. Simples. And we could say restart. There's a bunch of instructions you could use to fully customize your service, but this is very, you don't really need restart because there's not that much need for it. But anyways, for restart we could say until stop, unless stopped. Simple. You could also say restart on error, other things like that, but that's not really of our concern right now. We're just trying to get a Docker Compose file up and running. And we also need to define a volumes. Python applications make a cache file, and we don't want it to cause an error internally when it tries to make one. So we could just say data column /app/data. Because in our Docker file, we've said work directory /app, keeping it compatible with this. Now, I think this should be good enough. We also need to define a volumes instruction over here. We could say data. We can also define null instructions by just leaving them blank, and they could be filled in later. It's a very cool thing about YAML. Now, fun part. It is so easy to get up and running with Docker Compose. All you need to do is make sure you have Docker Compose installed. And what you need to do is write Docker Compose and then up. It's going to go through and it's going to build our Docker file for us. And there we go. Oh, seems like we have an error. It exited. But if we come here and we see our container, our application is built. Easy peasy. Okay, so there was a bit of an issue with some of the layers. These 3 layers were missing. So you have to update the actual application, the OS, to make sure that all these applications that were installed, they end up actually upgrading and applying the changes made to the OS. I'm not sure that's entirely true, but that's just my take on it. But make sure to apply these 3 layers to the Docker file. And if we try the same command again, and there we go. It has started the server in the Docker file. We're not running the server anywhere. It's completely running on the Docker container. Here we go. And if we were to click on the server, wait, let me. You can see it would show the activity. Now again, we have Dockerized this. We could ship this off anywhere we want using this as a complete package. There's no pip installs. All you need is a Docker file. Here's where things get a bit more simplistic. Now, Traefik is a reverse proxy akin to Nginx. Here you can see the motto: publishing and securing your containers has never been easier. Now, when people think reverse proxy, they think Nginx. Now, personally, I found Nginx a bit daunting with all the configurations and it not being an actual install. But there's a thing called Traefik, which is made in Go. It's even faster than Nginx, I won't even argue. It's made for Docker files. Now, personally, Docker is a great invention. You don't run into any version errors because all your OS versions have already been listed from this parent image. Whenever someone wants to run your application, it would run for them the same as it would run for you on your computer. If that's a big deal for you, then Traefik is definitely the way to go. Now, let's get started on getting Traefik up and running. So, in order to get started on Traefik, you need to go on traefik.hub, make it to the hub page, and you need to make an account. Now, we'll simply just log in to our accounts. We can use Google to quickly get up and running. And there we go. Welcome to Traefik Hub. If you don't have this page, please let me know. But for everyone else, well, let's continue. So we're at the Traefik Hub dashboard. It's very simple. There should be a button right here saying install my first Traefik Hub agent. Okay, add an agent. Now the platform, we're gonna select Docker Compose. And over here, it gives us very specific instructions on how to get your Docker Compose file up and running with the agent that we're going to add to our application. Now, this seems a lot. Please don't just copy and paste. I know there's a button right here for copy, but please don't just copy and paste all of this. This is supposed to run in the CMD. You can see by these quotation marks. that it's assigning a temporary variable and it will run the Docker Compose. We don't need that. But this right here is valid Docker Compose code. So this is how you would install it into your Docker Compose file. You can see it's saying services and it's also saying networks. Now, networks will go in the parent instructions. Okay. Traffic will go inside of our services. So right above app, or you could be below app, doesn't really matter. It will go right there. And for our hub agent, we'll do the same with what we did with Traefik. We'll just put it on top of Traefik right there. Make sure to indent that. Everything's inside of the services. And bam. Now make sure that this value, the hub.token, is the same that is shown over here. Just to make sure, we're gonna copy this agent token and we're gonna apply it to our hub.token. It didn't change anything, so it did the right configuration for us. Moving on. For our networks, just to be clear, we're gonna say external and we're going to say true. Now we have Traefik Hub and we also have Traefik's own network. So in order to expose Traefik's network outside of the Docker Compose, we're going to say, so like Traefik Hub, we're going to say Traefik network and we're going to indent this and Traefik will now be external. Very simple, very simple. Now let's go to the next page. Configuration is done. And time to run our application. Now just to make sure, run Docker Compose down. So it's going to shut down all our applications running on Docker Compose. And then we're going to write Docker Compose up. Cool thing about this is when we define image, instead of saying build, it would actually go and pull the image by itself and get everything up and running without you having to write your own Docker file. Okay, so there we go. Our application, our API, is now discovered on the Traefik's hub. So we'll just say how to host on Traefik. Easy. Go to agent details. Okay, now we can see our app, hub agent, and Traefik are all visible. Now we've missed a very crucial step. You can see over here, there's a networks instruction. Even for Traefik, there's a networks instruction. But our application does not have a networks instruction. So make sure to have the networks instruction and say Traefik Hub. Now we can restart our Traefik application. It's already picked it up. It will pick up where we dropped off from. So we're going to say Docker Compose down. And then we're going to say Docker Compose up. Now don't get stressed about deleting stuff, because all your configurations are right here and they will be picked up right where you left them. Okay, there we go. And you can see nothing changed. Now let's go inside of services. Let's select our application. And over here, we're going to say publish the service. Oh, it looks like running Docker down didn't work. Sometimes images, they don't rebuild. So in order to change that, what we're going to do is go to containers, select all, and then delete. Go to images, make sure to delete everything, clean up everything. And then run Docker Compose up again. I'm going to say D, just so it doesn't take over our terminal. When you write D, that stands for daemon mode. And it will do all its stuff and then return you to the terminal. But Docker desktop will pick up everything. So let's just wait for this to build. There we go. And we'll give it a second or two. And now if we refresh this. So this says there's no shared network between the service and Traefik. This is what would happen if you left out the networks Traefik Hub instruction for your application. Now make sure to write Traefik's Hub and not Traefik's network, because Hub is what's actually creating our services for us. Now that that's done, let's refresh this. Okay, so that issue we ran into simply because I didn't clean up again. I don't know how to fix that, but if you run into any issues with changes you've made to your application, make sure to just re-delete the application container. That fixed it for me, but if you run into any issues for why this service network says your application service could not be found on the network, please let me know in the comments down below and I will try my hardest to let you know where you might have went wrong. Now, if you followed along, make sure to get a good look at the application service. So we've defined the networks instruction, the volumes net instruction. We've defined our ports. We've exposed our ports. And we've built our Docker file application. And if we go back into the Docker containers, click on app, our application is running on localhost. Now, let's go ahead and publish this service. We're going to keep our ports and everything. And Traefik Hub will do its thing, publish our service, and bang. So it will make a link for you. If you click on that link, there we go. Now it runs on HTTPS, it's completely secured. Certificate is valid, and there you go. You successfully self-hosted your FastAPI application using Docker and Docker Compose. Now it's very simple using Docker Compose to append any services if you want. You can use PostgreSQL, you can use MySQL to host this. You could also append other application enhancers like RabbitMQ, Redis, all of that. If you actually go to images and you go to search, let's say up here, and you write Redis, you will see there are a ton of official and verified publisher images for you to try out and use. There's Circle CI Redis, there is Ubuntu dependent, and then there's Redis itself. If you type anything else like PostgreSQL, there you go. There's tons out there. This is why Docker is an essential when it comes to web development. It's very easy. It's not error prone at all. In fact, it does the opposite. And it lets you use cool frameworks like Traefik, which let you self-host on the cheap to make your APIs public with HTTPS. No fuss. All you've seen we've done is copy and pasted the instructions it gave us, and we're up and running for free. No VPSs, no money spent. This will stay running until your application is running. So if we were to stop our application, this would not respond. Meaning you have total control over your application. There's not some virtual machine running on some cloud in a wardrobe. It's all on your computer right in front of you. You choose what you need to do. And you can see that it's disappeared from the hub. Now let's rerun it and explore the hub a little bit. The cool thing I like about the dashboard is that it provides you with a lot of logging information. Very essential logging information, graphing, visuals that you wouldn't normally get if you were developing your own. You can see when you got the requests, the average response time, which is very useful for debugging your application's optimization. And yeah, that's basically it. You can define access controls, but I would not recommend that for beginner stages. If you want to get up and running, this is a great way to get up and running. And that's been Ronnie. Hopefully you guys learned as much as I've learned with this tutorial. Personally, I would not like to recommend people spend their money on virtual machines because we all have very powerful computers in our homes that we don't need to pay extra to get more computers where we can't even debug them as efficiently as we can with our own computers. Anyways, guys, take care and don't forget to innovate.